Hello everyone, this is Ayush, and I'll be now explaining the structure and the working of my fog and edge computing project simulation. So before we start, let me just show the network architecture as displayed here. You see all these edge devices, these are all sensors and actuators where the job that they do is basically they collect data and then they are subjected to a threshold value, and only when this threshold value is crossed is this data sent over to the fog level. So at the edge level, we have all of these sensors who have fixed threshold values. Now at the fog level, there are two main jobs. Number one, it collects data from all these sensors when they cross the threshold values, and then it takes a conscious decision, collecting data from various sensors and matching it, that whether some activity is happening right now or not. So when the when it concludes that some activity is happening based on this sensor data, it goes on to the second job of taking a camera input. And then this taken camera input is subjected to a deep learning algorithm of object detection, where it detects weapons and fire, in our case. So the fog level has enough resources to carry out this object detection algorithm over this video input. And this video input is, again to mention, only taken when the edge level devices give sufficient data to make this decision that there is some activity happening. Now, moving on to the cloud layer, what happens is this uh, fog layer, it carries out this deep learning algorithm. It takes in the result and then passes it on to the cloud layer, when the cloud layer makes the decision of informing the user or not. Now, the cloud layer now carries out two jobs itself. Number one is whether informing the user or not. Number two, it stores this result into the database in case of detection. It informs the user and it stores the result in database. Let me now kickstart the simulation. We start Node-RED. We just reload the software once. Here we see all these sensors. We zoom out to see the whole architecture as explained before. We see this architecture being displayed. We see all the random data being generated by these sensors for the purpose of this simulation. As soon as the threshold value is crossed by a certain number of sensors, this data is then sent forward to the fog layer, where the decision to take in the camera input is made. This is the debug console where we will be seeing the output. You see this data being generated by the sensor is completely randomized to increase the experience of the simulation. So we have to wait a little bit. Now we see that the camera input one has gone on standby. That means it is now preparing itself to take in the camera input. Now there was nothing of concern in the camera input. See that the deep learning algorithm that this employs has basically three classes for the purpose of this simulation. It has gun, it has knives, and then it also has fire. Now you see none of those three things are visible in the camera input, so we get object detected equal to false. Now this is being carried out various times as the randomized data is now kicking start these camera input simulations again and again. Camera input 2 can be now seen on standby. That means it is now getting ready to take the input. Consistently, we see camera input saying object detected false on the right side in the debug console. Again, we take a look at all the type of sensors that we have. We have temperature sensors, door and window contact sensors. We have sound and motion detectors. Completely randomized data generation. We see camera input 1 is again on standby. We now showed it a gun as an image, and it should then detect gun. See, as you can see, it says object detected true, gun, and we also see the query that it used to insert into the database. Now the thing is, at this instant, as you can see 0 minutes ago, it says object detected true, gun found. So the user has been informed by the cloud layer. Now we will also see that this is recorded into the database. So the memory function of the cloud layer is also witnessed here. Now, subsequently, as many times detection happens, that many times data is recorded into the database. And then maybe in the future, we can incorporate the thing where this data can be used to again judge the accuracy of the fog layer call, and the cloud layer then can make a decision of whether informing the user or not. That means it will employ a self-learning algorithm. So this was our Fog and Edge project, where we have designed a Fog and Edge architecture with various responsibilities being assigned at the edge layer, at the fog layer, and then at the cloud layer, depending on the requirements. The cloud layer requirements were the ability to interact with the user, as well as the ability to store information. For the fog layer, we needed processing capability to make the decision based on edge layer data, as well as carrying out the deep learning algorithm onto the camera input. And at the edge layer, we of course have the responsibility of collecting data and subjecting it to the selected threshold levels. Now here we show the camera input fire as well, to just to show that this is another class in our deep learning algorithm. And as you can see, it says object detected, true, fire found. And again, we see that another mail is received, fire found, as well as in the database here, fire.